Hey, hello guys. This might be boring for you guys, for some people that do not like electronics, but I like electronics. So I decided to continue working with this layout, in particular the Apex HV 23, and yeah, it's a really it come along really nicely, and I decided to remove the clipping circuit. Well, someone mentioned that it has to be synchronized with the input, something like that, but I'm not sure. I just eliminate the circuit. I don't think I really need it. Maybe I will just leave it there just in case it's working, because right now I still have the circuit here. The only thing I did, I just copy the same layout to avoid any further damage to the original design, because the original design should look like this. Let me see, I'm going to show you right quick. So this is the design that I placed the clipping circuit. So I decided to remove it. I still have space to place it here. Maybe I'm not sure if I'm going to place it again. The circuit. I had to move um, this fuse clipping. I'll probably move it close by here so I can have more room. Uh, I'm thinking that I do have 8 pairs here of power MOSFET. I think it's that just enough. It's plenty of MOSFET for the audio amplifier. I don't think it's needed to add in even more pairs, because you can get from this design about easily, without exaggerating, about 600 watts. Without reaching the clipping area. So the supply voltage for this amplifier is basically 75 volt DC, but I was increasing the voltage to about 95 volt DC, and there is some resistor that I add to protect the circuit. This one here, R27A and R27B, are the one that to control that current. So those are 330 ohms resistor. But if you are not going to use a higher voltage on the power supply, you can just use a jumper. Just place a jumper right there. One sample I'm going to show you right quick. Alright, let's make a jump. Wait, it's okay, don't worry about that. Just place a jumper. If you are not gonna use a higher voltage, just place a jumper right there. So you are going to use only 75 volt DC as the original schematic. So far I'm trying to figure out how I'm going to connect um, the output of the amplifier. It should be this one here. So I was thinking that I needed to do some changes here in order to connect the amplifier output. Should be connected here on this connection, and then after the relay engage, it will go through this inductor and the resistor. This is a 4.7 ohm resistor. It's a 3-watt resistor. I forgot to add the L1. L1 can be, it does not need to be perfect. L1 can be 1.5 microhenry. This should be fine. Yeah, 1.5. Sorry about that. 1.5 microhenry. It should be fine. So it's about it has to be a gauge or 18. No, sorry about that. It has to be like at least 14 gauge wire. So it should be 14 AWG wire. 14 AWG wire. About, I'm gonna put it right here. About 16 turns, probably, maybe less. 16 turns around a 10 millimeter diameter core. So I'm not sure if this is really needed, because on the real schematic it's not present on the schematic. So right now I'm going to show you that right quick. It's not present on the original schematic. It's not there, so I'm not sure about that. So I will place it there anyway. So I see most of the good amplifiers that have the inductor coil and stuff like that. So I'm gonna leave it there. It's okay. It's not a big deal. So now I gotta figure out how to connect this connection here, R55. It goes to the protection connection is right here. So what I can do is basically just trace a line. It's too far away from the, so I gotta figure out if I needed to move this like this. So probably I have to fix this to make it, well, yeah, it's okay, don't worry about that. So I can, gonna move this here so it's not gonna be that wider. That's the right word, I think. Okay, there you go. All right, so now I can move the protection circuit. Sadly, I was trying to simulate the circuit, but sadly there is no a. That's okay, don't worry about that. It happens. I forgot to put it all together into the circuit. It's okay, don't worry about that. So I gotta move this. I'm gonna rotate this resistor. There you go. So later on I can figure out how to. So I gotta. There you go, a lot better. Okay, I'm not sure if I'm going to just place a Faston connector, just like this one here, a Faston connector, just to connect this circuit. This is the output of the amplifier, so I'm not sure if I'm going to do that. Sorry about that. I'm not sure about it. So you know, just to place a Faston connector with a really thick wire and connect it here on this amp input. So this is the output for the speaker. So I'm not sure if I'm going to do that. So right now this resistor R55, it needs to be, it's right here, R55, it needs to be connected to the protection circuit. So it's this one here. I had to do some modifications here, and there is, I think this is AC and AC. One of the wire goes connected to the ground, so the only thing I gotta do is just trace a line to the ground right here. That's easy. I can do that. That's no problem. So I gotta figure out how to do those connections there, and I think I gotta move this protection circuit, the fuse clippers, something like that. So it's okay. Fuses, I gotta move them away from the. It's okay. All right. Be aware that this circuit will have 75 volt DC. That's pretty a dangerous situation right there. So I really don't recommend it to deal with high voltages of audio amplifier. You don't know what you don't know what you're doing. So you gotta be really careful about this. So I only do this because I know how to deal with these high voltages. It's kind of, it's like one technician that told me when I was studying electronics in the army. They told me work with one hand and the other one in your back, just to make sure that you don't complete the circuit. If you complete the circuit, you know you know what I mean. If you complete the circuit, you're done. Completely done. Because the current, if the current goes through your body with just a few milliamps, you're a dead man. So that's for sure. So you gotta be really careful about this. So I always joking about it. Sometimes I make videos that are not, you know, just to make it a little bit interesting. I just joke about it a little bit, but it is dangerous. So don't play with the high voltages. This is a dangerous situation. Always be careful with this. Okay, they're gonna clone this zone copper area and go up. Maybe the PCB is way too large, but maybe I wanted to try it out. I'm not sure. I'm kind of short on money, so that's why I have not tried out this. So alright, let me see. So now I eliminate that. I do have space. Oh, the amplify input is gonna be a little bit difficult to, unless I create the connection here. Let me just make some modifications here. So alright, as you can see, there is a blue dot right on the zone, so that means that you can edit and move it around. You can see I can just move up or down the zone, so I can, you know, make some changes on the PCB. There's another one here. Let me see. There you go. It's green. I think I might be able to just place a trace from here down here, but I need to make a connection first, so it's gonna be difficult to do that. Or maybe just a piece of wire from here to here. It should be fine, I think. Let me see. Split the group. I gotta make sure so you guys can see what I mean. Okay, split the group. One connection from here to here. Sorry about that. Here, gotta leave. Jesus Christ. From here to here, I can place a thick piece of wire to make that connection instead of make the trace. I'm not sure about that. I gotta think about it. Not sure. All right. Let me see. Let me complete the connection here. All right. So gotta complete the circuit. All right. Over here. Yeah, well, it was saving the. There you go. Oh my God, I was close. I almost got it. Oh wow. Oh my God. Oh, what the hell happened here? Oh, okay, I see what happened. Don't worry about it. Alright, gonna remove this. Make it straight. There you go. And alright, there you go. So it looks ugly. Something happened. I think this trace is thicker than the other one. This one is okay. Let's go 20. There you go. It's all like correct. Plenty of space, I think. I'm not sure. I'm not sure about it. I was thinking to rotate the circuit. I'm not sure. All right, I'll figure out that later. Don't worry about it. Okay, let me see. All right. There's a fuse connection. There you go. It needs some protection, so. Alright, let me see. I got plenty of space there, man. I was thinking that I'm not sure if going to rotate the circuit or leave space. I was thinking okay, I removed the clipping circuit, so I still got plenty of space to put back again the clipping circuit. I need to have the solver connection. I forgot to do that. I'm thinking. Alright, so let me see. Gonna select this and this and this. Let's see. Build group. Alright, let me see. Uh-oh, I forgot one. I forgot one component. This 12 volt AC. That's okay. I'm gonna move this away from the circuit. And I forgot one more. It's okay, don't worry about that. It's okay. Build group. I'm gonna move all the way. There you go. Alright. Build the group again, and there you go, all complete. So I still have plenty of space for the clipping circuit. I'm not sure if I'm going to install that back again. I'm not sure. Should I rotate this? I'm not sure. Alright. One more component I forgot. Alright, there you go. So okay. Let me see. Gonna clone these components, rotate them. No. Okay. No, it's okay. Alright, let me see. I'm going to place this here. I'm going to move this over here. No, it's not gonna look. Okay, right there. Let me see. Nope. Oh man, I'm thinking this is a really difficult situation right here that I have. I'm not sure about this. Oh my goodness. Because I have the ground here. I don't know. I cannot. Alright, let me see. Thinking. I am thinking. I think I can just move this back the way it was before. So yeah, so I have more space for the ground because I don't have the ground on the output of this area is the output of the amplifier. So I'm not sure about this. As you can see, this is the output. So it should be connected here on amp. Alright guys, I'm gonna cut the video. I'm just uploading this video so you guys can see what I'm doing right now. It's kind of interesting situation that I have here. Bueno, para los que hablan español, estoy tratando de figurarme cómo puedo conectar la salida. Va conectada aquí, no estoy seguro si dejarlo así como está y hacerlo a través de alambre o si no tirar un trazo aquí para que esté conectado aquí sin tener que poner un jumper, un alambre. Eso es lo que estoy tratando de evitar. Entonces yo moví esto. Yo creo que lo voy a poner como estaba porque no me gusta la idea de que no tenga espacio para... Eso no es nada, yo lo arreglo ahora. Eso no se preocupen por eso. Eso yo lo arreglo ahora mismo. Eso no es tan difícil. Gotta move this the way it was before. So I need to have space. I need to have space for the ground and the... So I think I can have that space here. So ahora mismo tengo espacio aquí, as you can see. Now I have space, but not enough. So I gotta move this up. I think I almost got it there. Casi lo tengo ahí, muchachos. Porque ahora mismo tengo espacio para el trazo que va aquí conectado, para la entrada que va aquí en el relay, y esta es la salida con la bobina, ¿ve? Como pueden ver ahí. I think I almost got it. Almost. So also I need the ground. I need the ground for the shovel. So yep. The ground I need it. I need it badly. Okay, I see. I got it. I can see it right now. I can see it right now. This is the filtering C11. Este es el C11. Míralo aquí. 100 nanofaradios. Va conectado a ground. Y esta es la resistencia 4.7 ohmios. No la estoy viendo aquí. Aparentemente no la veo. So, tengo que poner una resistencia en la salida. Va aquí conectada. Entonces este capacitor lo puedo poner más o menos por aquí. Oh, espérate, vamos a hacer una cosa. Ahí está. Entonces pongo la resistencia esta. Vamos a split the group. So, esta R50, necesito R11. R11. Ahí está. La cloneo y esta es R11. There you go, R11. So esa es la que va en el filtrado de la salida que va a entrar aquí. So tiene que estar alineado a este que está aquí. Como pueden ver ahí. Entonces este va conectado acá. So, esto lo puedo mover un poquito más para abajo. Entonces hago la conexión ahí. Por ahora lo voy a poner así, después yo lo modifico poco a poco. O sea, no, o sea, ahí va conectado. Ah, espérate, quedó finito. Tiene que ser grueso. Ahí está. Muy bien. Entonces, aquí entra la salida. So, tengo que hacer la conexión aquí. Vamos a hacerlo ahora mismo. So I decided to go ahead and continue with this work. As you can see, guys. Ay, el inglés mío está malísimo. Pero anyway. My English is terrible. I know that. I know that it's terrible. I don't care. So what the hell are you talking about, bro? Okay, so voy a continuar aquí. Okay. I need the ground. Yo creo que ahí está bien, figúrate. Ahí está saliendo la salida. Pero necesito espacio. Está quedando bien, fíjate. Ahí no está nada mal. Voy a tener que hacer algunas modificaciones aquí. Déjame una cosa. Digo que va conectado aquí. Ahí está. Está un poquito grueso, ¿verdad? Este se está salvando ahora el proyecto. Este es 20. Debemos ponerle 20 para que esté todo igual. Ok. So, ahí está la salida. Se supone... Está la salida del amplificador, ok. Pero... Esto lo puedo hacer un chipito más arriba para que tenga más material de cobre. Ok, ahí está. More copper material. This should be 20. This one here 22. El grosor, estamos hablando del grosor de... Ok, there you go. So, ahí está la conexión. Se ve un poquito rara. Sí, porque la salida va a caer aquí. El relay enciende, pasa a través de esta bobina y esta es la salida. Es mejor que tener eso a no tener nada, ¿verdad que sí? So, ahora esto lo puedo extender, que es el ground el ground del amplificador. Vamos a extenderlo. Perdón, el ground que va conectado al capacitor. So, vamos a hacer la conexión aquí. Vamos a ver, ahí está. Y vamos a conectar el filtrado. Ah, ok, muy bien, muy bien. Hay bastante espacio en la placa. La placa tiene muchos áreas vacías. Está un poco difícil pensar. Lo que me está preocupando es que si este amplificador puede dar hasta 1000 vatios, esta zona aquí no es lo suficientemente ancha para que pase toda esa corriente. Recuerden que este amplificador da hasta 1000 vatios. Eso es lo que me está preocupando a mí. Ahora mismo aquí pasan 1000. Digo, resiste 1000 vatios. No, suple 1000 vatios, que esa es la palabra correcta. Está difícil. Está difícil ahora. Lo que pasa es que el área del fuse clip me está quitando, no me deja. Eso es lo que me está preocupando a mí. Debe de ser un poco más grueso. Me tiene pensando eso. A menos que yo alargue esta zona, la haga un poco más ancha. Digo, menos ancha, perdón. Un poquito menos ancha, yo creo que sería lo correcto, ¿no? Un poquito menos ancha. Ahí está. Oh my god. Okay, ahí está. Entonces, para aumentar el grosor de este trazo, porque recuerda que mucha corriente va a pasar en esa área de circuitos, o necesito hacer este trazo. Esta zona de cobre tiene que ser un poco más gruesa para que así pueda pasar la corriente, porque va mucha corriente. Ahí está un poquito mejor, porque creo que el trazo este es de, pasan 20.3 amperes, y si yo lo pongo aquí, vamos a hacer una prueba. Este de cuán grueso es. Esto es de 660. 660. Vamos a ver cuál es la si es lo suficientemente grueso para que pase corriente. Ok, 660. Sí, porque el programa lo dice básicamente cuando tú lo pones el trazo. Ok, vamos a ver cuánto sería. Ahí está. Este, si lo pongo aquí, comparo. Dice 20.3 amperes, o esta zona está bien. Ahí pasan 20 amperes por aquí en esta zona. Fíjate, no he medido la corriente que pasa a través del circuito. Eso es lo que tengo que también mirar. Mirar eso, a ver. Esta es la salida. Está aquí mismo ubicada. Entonces esta zona la puedo hacer un poco más gruesa también, para que pase corriente bien. Hasta 20 amperes máximo es bastante. Bueno, muchachos, voy a cortar el video que ya está muy largo, y espero que les guste este video. Suscríbanse a mi canal. Voy a continuar con esto. Esta figura está interesante. Voy a seguir a ver si lo termino, y si lo termino y está todo bien, pues puedo compartir la data por si ustedes lo quieren tratar. Un poquito riesgoso, para serles sincero. Este amplificador usa voltajes muy altos y no quiero que les pase algo a ustedes. Es muy peligroso, tienen que tener cuidado. Cuando lo termine, pues sí, voy a dejar la data en PDF para que si lo quieren hacer a plancha. El único problema es que el PCB ya mide más de 325 milímetros. Ahora mismo creo que hoy le añadí unos milímetros más adicionales. Déjame, antes que corte el video, lo voy a mostrar. 366 milímetros. Holy shit, esta placa es demasiado grande. Esta placa es muy grande. Bueno, eso es todo, amigos. Bueno, que pasen un buen día.